All right, I'm going to be talking to you guys about systemd-nspawn and containers in general. Going to be going over some of the Salt support, some of the more raw Salt support that we have. Now, before I dive in, I want to talk a little bit about what is the difference between these container technologies. What are the container technologies that are out there? And so, you all know about Docker. It's kind of hard to not know about Docker. My grandmother knows about Docker. I have LXC, the original, which of course it isn't. And Rocket, and then nspawn. And of course, there's OpenVZ. There's Linux vServer. Are there any container technologies that I'm missing? What? Oh yeah, Ubuntu's making one. Hopefully it'll be, oh, I shouldn't say that. Okay. We're going to be walking through using nspawn and talking a little bit about Salt's integration with nspawn. And so I need to start by talking a little bit about what are the differences between some of these different container systems. Now, one of the main things that we run into and are running into right now has to do with the fact that we have technology which is focused towards people who are writing front ends or generally call themselves developers. And we have technologies that are focused towards the back end and server management. And there's a lot of people out there who are out there saying, oh, we're going to get rid of the server back end guys, it's all front end developers. Or they're out there saying that if we write the right technology, we'll just get along with, we'll stop fighting each other. But in my observation, it doesn't seem to really be working in most cases. Infrastructure people still seem to hate developers, and developers still seem to hate infrastructure people. And I think that what's going on inside of container land actually emphasizes this a lot. We're starting to see a lot of deployments of people using LXC and nspawn containers in production environments. And we've run into a lot of situations where they've said, hey, we got all excited about Docker, we put it in production, and we said, nah, we don't like it in production. Now let me backpedal a little. I've seen plenty of people who say they do like it in production. But the reality is that when we look across the spectrum of the containers, there are certain containers that have features and functionality which are more directly targeted towards running them in a production environment. They can act more like a virtual machine. They can be more independent with respect to how their networking stacks are configured. And they don't necessarily force you into certain methodologies for running your underlying applications. And so that's why when it comes to Salt, we end up seeing a large variety of users across multiple container technologies. Also, I think that that has to do with the fact that people who use Salt are generally people who are open to trying many, many, many different options. So we have very good support for Docker inside of Salt right now. We also have very good support for LXC. So using Salt, it's very easy to spin up LXC containers, spin them down, create them, bootstrap them, make them app containers, make them full stack containers. We don't care. We're Salt. We just give you the tools to build your infrastructure. We don't give you the doctrine to build your infrastructure. But so one of the things that I'm really excited about with nspawn, or rather the reason why I'm really excited about nspawn and why I wanted to talk about nspawn, is because of how tightly integrated it is with systemd, because it's part of systemd, which, whether you like systemd or not, it seems to be winning, so we might as well support it. So, what we're doing, and why I wanted to talk about this again, is just to say we do all the container things. We've got support for underlying container execution, runtimes, building container deployments. We've got support for bypassing all sorts of network isms inside of Docker, et cetera, et cetera. We're Salt. We build support for all the things and all the containers. nspawn is an incredibly elegant, very new container technology with respect to its ability to be used on production systems. And so, there's a couple of things that are very, very beneficial. And yes, we will be demoing this as of systemd 2.19, which added a number of extra features in systemd-nspawn. But systemd-nspawn is made to be able to work with images from a number of sources, Docker images, virtual machine images, tarballs containing image data. It's under ridiculously active development, like admittedly all of the container technologies are right now. But it's already on your system. Whether you like it or not, if you're running a systemd system, you already have nspawn installed. So it's hard to beat that for, setup cost. Okay. So the first thing I want to talk about is just some of the basics of using nspawn in a very raw way. So nspawn is a fairly raw container technology. It doesn't have image snapshotting stuff like Docker. It's all about making a container and running that container or running an application in that container. And so the first thing that we want to talk about is just what it takes to actually build a container. So, of course, we can... You've got a demo lined up for this one, right? Yeah. Is the Wi-Fi that bad? Yeah. Okay. I thought maybe later we could do bootstrap install onto a container. Okay, we can do that. That's less to download. That's a lot less to download. Okay. Running an nspawn container is incredibly easy. This line right here is all you've got to do. Nspawn, give the path to the container. Huh? Yeah, B for boot, D for directory, and you're done. You boot into your container. Yeah, let's do that. There's a number of additional options that you can run when you hop into a container. This will boot up a container and just give you a login prompt. Anytime. So what I wanted to do was first talk about nspawn in a raw sense, but then come back and talk about some of the Salt integrations, and then talk about how those Salt integrations are also available for others. Okay. So pretty straightforward. Well, we have a container. Okay. Now, the systemd-nspawn command can spin up your containers. You can pass in a number of different network options and arguments so that it's very, very easy to expose a lot of the network functionality of systemd. But that command obviously is directly dropping you into a container, which typically isn't what you want to do, especially from a deployment perspective. Typically what you want to do from a deployment perspective is that you want to be able to run a container in the background, have all of its networking and all of its sauce set up on your behalf. And this is where the machinectl command comes in. So machinectl enables you to spin up and manage all of your containers, again, in the background. And so whether or not you're spinning them up, it also has the capabilities to just run a single command in a container so that you don't have to have an init running within the container. Since it is systemd and you would be running a systemd container within a systemd runtime, it is able to short circuit to a certain extent that init process, so that it is a very, very lightweight init process which means that you're not sacrificing any of your operating system runtime services within that actual container to run it, as opposed to just saying, hey, we are only going to be running whatever the magical network interface is built into this container's runtime system. Okay? So, machine control starts, stops, manages, runs commands inside, et cetera, et cetera, et cetera. Okay. So the next question is networking. I've alluded to networking a number of times with respect to nspawn. Nspawn does have built-in support for network bridges. So your nspawn container can have its own virtual Ethernet device. It also can share the host's network interface. So that makes it very, very easy to spin up containers that are just running on the same IP address as your host. It also has something which is quite slick, which is the virtual macadder VLAN. So it virtualizes your macadder so that you don't actually need to have a network bridge to get another logical Ethernet connection, which makes it a lot easier to get multiple IP addresses relative to one machine when you're in a situation where a bridge is cumbersome, like we all are right now with laptops. Okay? So the virtual VLAN is a pretty slick way to go. All right, so the brief overview of nspawn. Now we got to talk about Salt stuff. So that's more exciting. I mean, from my perspective, for obvious reasons. Now, the systemd-nspawn integration that we have written has been based on systemd 2.18. It's got some features that are only available in systemd-nspawn 2.19. And we'll be talking about what some of those differences are. It's in the current development branch, as you may guess, based on the fact that it wouldn't have worked when we feature froze the last release. And all of the functionality, again, that we're going to be talking about is also baseline available for LXC containers as well. So again, we don't really care about the underlying container technology. This is mostly us going over a high-level view of Salt has all the functionality to manage containers. Now, in systemd-nspawn, we currently do have support for bootstrapping containers, deciding whether or not you want that container to be running a Salt minion or not, bootstrapping a Salt minion if you want to, auto-accepting keys, as well as executing routines inside of those respective containers. Okay. And then by the time we come out with Beryllium, we will also have states for these containers. And if we've got time, we'll circle back around and look at the already developed LXC container systems. So, if we want to generate a new container, we have these routines built into Salt. So let's say that you want to build a container from the ether, from the thin air. All you've got to do is say nspawn.bootstrap container and then give the container a name and a platform. So we're missing. Platform will default to the platform that you are running the minion on that you're executing.
You don't have to have bootstrap on your machine. You can't run.
Right. So let me I'll clarify. Don't worry. I got Erik all upset. It's not that hard. Okay. If you say bootstrap container, it will assume that you want to make a container that is the same OS as the host. So if you're running on a Fedora or a Red Hat system, it will try and bootstrap using Yum, a similar system. Same if you're running on Arch or Debian, et cetera, et cetera. But you can specify a different operating system to bootstrap the container as. You just need to make sure that the right software is installed to be able to pull it off. So if you're running on a Red Hat host and you want to bootstrap a Debian system, debootstrap is going to need to be installed on that host. Otherwise, you'll get an error message back that says, we can't do what you want us to do. But that will go out and it'll make the container and you don't have to bat an eye. Okay? Now, right, downloading all of the files to bootstrap a container does take a few minutes on a fiber connection. And we have bad conference Wi-Fi. So we've already got containers that we're gonna work with here. Now, there's a couple other mechanisms that you've got inside of SaltStack support, pullraw and pulltar. Pullraw allows you to pull a virtual machine image from a HTTP source. Any other sources, or just HTTP still? Okay. Pull from an HTTP source an existing virtual machine image. So a QCOW image or a raw image are the ones that are currently supported. And then it will convert that virtual machine image into a container so that it can be, and register it with the system under the name that you pass in. So a very convenient way to say I've got virtual machine image A and I want to see how, make sure it runs as a container. nspawn is pretty darn good at being able to boot a lot of different arbitrary operating systems. They don't need to run they don't need to have systemd in the container operating system to run it. That's a normal misconception, primarily because they used to always need that. But they've fixed that, so it's a lot easier now. I asked you if HTTP and HTTPS were available, and it was right on the, that's why you're smirking at me like I'm some kind of moron. I must be just exhausted. Okay. It is also all optimized to run on Btrfs. Again, nspawn is very next generation. Now, if I want to switch gears really quickly and talk about Salt support for LXC, Salt has support for grabbing LXC images from a number of different sources and mechanisms as well, and deploying them directly on a file system or on LVM. So if you were to choose to use LXC, we've got, again, a lot of flexibility around how you can use Salt to deploy your images, build your images, etc., etc. And then, of course, we have support for Docker images inside of nspawn. Hey, did we ever get support for Docker images inside of LXC? Oh, I've got a script that converts them. We need to get that in there. Yeah, it's not hard. So we'll get Docker image support in for LXC as well. But so the pull Docker, or DKR, allows you to reference a container on a Docker index somewhere, whether that's a public index, private index, et cetera, et cetera. All right. Finally, let's say that we want to set up a salt minion inside of the nspawn container that we've created. So I know that there's all the arguments about if you're doing more than just running your app in a container, you're doing it wrong. But again, we've run into many situations where people want to do many different things depending on how they want to run their infrastructure. It is prudent to remember that when we're out there deploying containers, I want you all to think about all of the virtual machines that you have deployed, and that you deployed those virtual machines and said, I'm going to delete that virtual machine in 2 weeks and replace it with a new one. And think about how many times that didn't happen. Just because we say, hey, we've got a container way of deploying these things in such a way that they're never going to go away, that doesn't mean that that's what the reality is going to be when we actually start managing our infrastructures. It's a wonderful dream, and when people who pull it off, that's great. Beautiful infrastructures. But we live in a world where I can promise you that there is going to be a huge swaths of containers that are going to be getting literally maintained. within their containers, whether you like it or not. That's what's going to happen. And so that's why we support installing Salt inside of containers. And so nspawn bootstrap Salt inside of the container will, from the host that the minion's on, the host for the containers, it will execute the commands inside the container to bootstrap Salt, get Salt installed properly, and it'll pre-authenticate that container's minion's keys for you. Because again, it's easy, I shouldn't say easy, it's plausible to pre-authenticate minion keys when you control the mechanism to initiate the minion. Hence why we can do it with Salt Cloud, right? Okay. So, Erik, can we just start demoing some of these? We've got all this demo stuff taken care of, and I feel like I must, not be, something's wrong. I don't have the usual energy. Okay, let's do it. That's a live demo of new code. It's in the develop branch. So it's got to be started still? We'll fix that. Okay, so we can run commands directly inside of the container.
Now, this is just a minion log here, so you can see it running.
Oh, the minion log of executing the bootstrap inside of the container, and then the log has debug on, so we can see all of the routines that are happening inside of the container in the host log.
Yeah, that won't be exposed normally, but I just have debug logging on here.
Okay. Yeah, that didn't help. Here.
These commands here are all, they'll kind of share the CMD module, so you can, if you ever run command, or shell command,
Yeah, so all of the run commands mirror the CMD run commands that are inside of Salt. So if you guys aren't familiar with the CMD commands, this is one of the most common problems that I run into with people who use Salt is that they come back and they use cmd.run to tons of stuff because they don't realize that there's modules to do everything. You know what I'm talking about? And then they don't realize that we've got things like cmd.runAll that gives you this nice summary and a dictionary of the attributes of everything that happened. We have put a lot of work into making sure that the underlying execution module libraries for all of these routines are incredibly robust, so that you've got just a huge amount. Yeah, pass an argument. So you've got a huge amount of information that's available. Okay. So you can list your available, you can list all of your available containers, your running containers. All of the basic functionality is there for, again, just managing everything. All right. Now my next question for Erik. Sorry, what were you trying to say, Erik? Oh, slow Wi-Fi. It's tragic. The next question I want to ask you, Erik, you don't happen to have an LXC demo ready, do you?
I have LXC containers on my laptop.
Okay, fine.
Do things with them, like start them, restart them, run them.
So our support for LXC is a lot more robust at this point. So within LXC, we do have states as well as execution modules so that you can define exactly from a stateful perspective what types of containers you want to have deployed. You can also define exactly what their network topologies and infrastructures look like, define from a stateful way whether or not you want them to be bootstrapped with Salt or not, define whether or not you're going to be spinning up app containers or full stack containers, et cetera, et cetera. So all of that information can be configured via Salt. Now there's another piece of functionality that's new to Salt that I want to highlight on really quickly that some of you may have heard some whisperings about throughout the conference. And so we're going to shortly be adding a feature for this for both LXC and nspawn and perhaps Docker if we can find the right angle. But we recently also introduced a system to Salt called beacons. Now, has anyone in here heard about beacons yet? Wow, we've done a really good job of yelling and screaming about that. It was also the previous session. Oh, good. So yeah, we were able to bootstrap a minion on there, automatically authenticated with it. Automatically gets authenticated with or it hooks into the master. It didn't authenticate. Is that not in there?
With LXC, we did that with the init wrapper, and it will create bootstrap and pre-auth.
Oh, so we've got it for LXC, but we're not quite done with nspawn yet. Okay. Makes for a less fantastic demo. We had to accept the key. Okay, so one of the things that we're really excited about when it comes to beacons is that when it comes to container management and beacons, these container management systems have event wrapping interfaces that we can watch. It's easy to go into machine control for nspawn. It's easy to go into Docker's tools and find out if any events have happened relative to your container systems. And then have those events get piped back up to the Salt master. So that again, we have all of that awareness going into the reactor. But we've also introduced a sister system to beacons called engines. Dave probably mentioned engines in the previous talk, right? No? I got something. Okay, so the reason that I'm really excited about engines is that for those of you who are familiar with the Salt reactor it's slick stuff. You can get events, you can react to them. But the problem that we run into is that it is still a very much so bring your own mechanism to the party for the reactor. The engine's idea is so that we can make high-level applications within the master that can listen to the event stream and make more complex decisions. So that it's much easier to have an engine that is listening to the events coming out of your arbitrary container interfaces, coalescing those events, and making decisions about how to manage them in a fully autonomous way. And so the idea there being, or I should say the concept that we are developing there being, that we can have an engine that receives all of the routines relative to what containers are up and running, can receive heartbeats about all of the containers that are in the system, coalesces it inside of this engine routine so that it's very, very easy for it to make decisions about where to spin up new containers, whether it should spin down containers, but also, since this is Salt, we still have full control access to the underlying systems. So we can query any arbitrary information that you want from the underlying operating systems as well. So that what we begin to look at is making a highly customized picture of what we want our loads to be, instead of just making scaling determinations and bin packing determinations. So I should explain bin packing. Bin packing is the concept of saying that we've got n number of buckets, and they need to be packed inside of each other in the most efficient way possible. This is a very serious problem when it comes to resource allocation in containerized and virtualized environments. Generally, we just do everything by load. But the problem that we run into, and the problem that we've seen very regularly, is that people don't want to just do it by load. They want to do it also by business drivers, by SLA drivers, by saying, I want these systems to automatically rebalance themselves based on a combination of load, TCP connections into their web servers, and how long it's taking that system to process something that is specific to my application. So that they can go back and say, we have a system in place that can promise that routine X is never going to take more than 8 seconds. Okay? Because as soon as they get to a threshold that's encroaching that for that metric, then they're able to send signals back in that say, I don't care what the load looks like. Something is potentially wrong with this system that isn't allowing me to hit my the fundamental purpose of this device. Give me more of them. Rebalance automatically. Or at least wake somebody the heck up. Okay? And so those fundamental drivers is a big part of what we're currently developing with respect to the beacons and engines inside of Salt, and with respect to containerization. Because, again, it's not about, if we look at the PaaS movement, the platform as a service movement, it hasn't gained anywhere near as much traction traditionally because the platform bins that they wanted you to put everything in were too specific, right? But we're developing infrastructures around containerization that is also very specific relative to how to deploy those containers. And so our approach is to follow the same Salt mantra that we present all of the tooling to be able to build a specific architecture to your needs for your specific deployment, instead of coming back and saying, I, who have never seen your infrastructure or what you want to do, have a plan for you. I'd much rather present you with the tools and develop the tools and then develop the people and the expertise around those tools so that you can get deployed the infrastructure that you need, not the infrastructure that some guy thinks is a good idea. Okay? All right. So we've got a number of new features that we're currently working on with nspawn and LXC. around just making that fundamental management continually more and more and more and more robust. All right. Now, does anybody have any questions, comments, arguments, rotten fruit? Okay. The question is that we've seen the problem with reactors where you'll get the same event over and over and over again, and so you'll react to it over and over and over and over again. And is engines a way to alleviate this? Very much so. Because the whole idea of engines is that we're now, instead of just having a flat reactor that receives an event and then goes, what we're able to do instead is write an engine that says we have ingested these events and we know to execute based on certain intervals or customizable interfaces relative to those events, so that it can do a lot more data parsing, data crunching about the events. It can do a lot more work around saying, if I'm getting a stream of event Y, I'm only going to react to it every 20 minutes. These sorts of compound routines are exactly what we're trying to solve with engines. Okay, yes? Yes. There are a lot of schedulers out there that it would make a ton of sense for this to be able to directly access. And so a lot of that also comes back into the bin packing argument. So it makes a lot of sense, like you're saying, to be able to hook into another API. The engine system is an open plugin interface for Salt. So engines that are created are pure Python, which means that it should be very, very easy to be able to translate and pipe that information into their respective underlying schedulers, and then pull information out of those schedulers. And we look at something like Kubernetes. I mean, it's all JSON-based, REST API. It should be perfectly reasonable to be able to pull that information out and combine the information from someone else's scheduler with your own business needs, and then make determinations. Is that what you're asking? Okay, thanks. Our engine's a state, I should have given a talk on engines. Admittedly, engines didn't work when I put this talk on the lineup. Okay, the vision for engines is primarily that we can make targeted applications that run relative to an event stream or other arbitrary data on the master. And so that means that it's trivial for us to create an engine that is running states, but it's also...
I don't mean states as salt states. I mean, like when a reactor fires, you don't know what the previous state the last time the fire was.
Oh. Yes, engines are definitely useful for that. Basically, yes. Yeah. Yep, so that you can stream process your events so that you can make compound decisions instead of just one-off reactions over and over and over and over and over again. When can you have it? Engines are in develop right now, and they will be released in the Beryllium release of Salt. I think we've got 3 engines in there, or at least pull recs for them, because since I mentioned them yesterday, 2 engines have been written. So if you want to look at the code, let's open up an engine. I got 3 minutes. Engines are, like all plugins in Salt, a very straightforward thing to write. Now, I think that we're probably only going to have, yep, there they are. Yeah, we've only got test in here because the others are within pull requests. So all you've got to do, the test engine is, it's like test.py. One, engines are made to be available on the master or the minion. Also, in the next release of Salt, the reactor is going to be made available on the minion as well. So for anybody who likes to think that way, can has. There's a much more, I got a very confused look, like, why would you want a reactor on the minion?
No, when you said next release, which release did you mean? Did you mean beryllium or?
Sorry, beryllium. I'm talking about beryllium, not lithium. Lithium is like done. And it's an RC2, and I'm not about to shove new features into it. Okay. All right, no, I know. You give me that look that says, but Tom, you merged that feature pull request for a new AWS module. Sorry. Is Ryan Lane in here for me to yell at him for giving me stuff that late? So, all we're doing in here, there's a much more elegant way to initialize the event bus, just so you know. All we're doing in here is initializing a connection to the event bus, and then in a loop, getting events and dumping them to JSON. So the interface is very, very, very raw. Okay? And so we're going to have a number of engines out that give very basic examples about how to aggregate events, how to aggregate them in a clean way, how to put those events inside of data stores on the master or off the master so that these processes can be making those complex decisions. The other thing about engines to keep in mind is that a lot of Salt's plugins are made to exist entirely inside of one Python file, right? But I definitely see larger applications existing plugged into the engine system. I think it's going to make a lot more sense that we would see an independent repository somewhere that says this is an engine that you install, and Salt comes with a plugin that just hooks into an external engine. Okay? So this is definitely one of the most ambitious plugin interfaces that we have created, because it's really plugging in Salt's connection systems in a very natural way into an arbitrary external application to do compound routines on top of Salt. Okay? So yeah, we are planning on producing a bunch of engines, and in many ways to work in harmony with the beacons that we are pumping out like mad. I'm really excited. I got a good idea for a beacon, one that, tell me if you think this is a good idea. I got you. And I've got negative 47 seconds. So it's the idea of a beacon that is listening to everyone's shells. And so as soon as somebody says enter to saying yum install foo or open up to edit this file, the action of saying enter in the shell gets converted into an event, so that then you can have a central location that is logging all of the shell routines that are happening on all of your infrastructure as they happen. Does that sound appealing to anyone? Show of hands? Okay. No, it can, yeah, no, it's certainly easy to do by shifting logs around. It's definitely re-implementing audit log. I'm just asking if you think it's a good idea to do it in Salt. Gareth. All right, fine. Fine, my example isn't perfect. Gareth is on my side. punks. Okay, any other questions? All right. Yo, hey, guy with the fantastic chops. Since app containers are effectively tarballs with manifests in them, will that work with pull-tar? That is what pull-tar is made to do. So yes. Thank you for asking. I didn't give like a nice crisp explanation of that. Yeah.
What about any sort of plans for volume management for data permanence or impermanence as regards to containers?
Okay. So when it comes to volume management, we've got volume management built in for LVM, for LXC. We've got it built in for Btrfs, for nspawn. And so, yeah, we're continually building in more custom volume management. Okay. We good? Should I release you? All right. Thanks for coming.